Hello everyone. This is our second video of a video explanation of internal series day 1 test 2. In this video we will going to discuss algorithm for decision tree induction, attribute selection measures and mathematical expressions of information gain, Gini index, reduction in impurity, concept of overfitting and tree pruning. This is our all the questions of second internal test. Question number 1. Uh, to write algorithm for decision tree induction, first we need to understand definition of decision tree. So the what is decision tree? Decision tree is a supervised learning technique that can be used for both classifications and regression problems, but mostly it is preferred for solving classification problems. It is a tree structured classifier where internal nodes represent the features of dataset, branches represent decision rules, and each leaf node represent the outcome. One attractive classification method involves the construction of a decision tree, a collection of decision nodes connected by branches extending downward from the root node until terminating in leaf nodes. Beginning at the root node, which by convention is placed at the top of the decision tree diagram, attributes are tested at the decision nodes with each possible outcome resulting in a branch. Each branch then leads either to another decision node or to a terminating leaf node. Algorithm for decision tree induction. This is basic algorithm, a greedy algorithm. First, tree is constructed in a top-down recursive divide and conquer manner. At start, all the training examples are at the root. Attributes are categorical. If continuous values, they are discretized in advance. Examples are partitioned recursively based on selected attributes. Test attributes are selected on the basis of a heuristic or statistical measures. For example, information gain, conditions for stopping partitioning. All example for a given node belong to the same class. There are no remaining attributes for further partitioning. Majority voting is employed for classifying the leaf. There are no samples left. This is the basic block diagram of decision tree. And note that a decision tree can contain categorical data, yes or no, as well as a numeric data. Now, second, what is attribute selection measures and explain three of them. So, it is a heuristic approach to select the best splitting criterion that separates a given data partition. D of class label training tuples into individual classes. Splitting criterion is called the best when after splitting each partition will be pure. A partition is called pure when all the tuples that fall into the partition belongs to the same class. Attribute selection measures are also known as splitting rule because they determine how the tuples at a given node are to be split. First, a rank is provided for each attribute that describes the training tuples, and the attribute having the best score for the measure is chosen as the splitting attributes for the given tuples. According to the algorithm, the tree node created for partition D is labeled with the splitting criterion and the tuples are partitioned accordingly. There are three popular attribute selection measures: information gain, gain ratio, and Gini index. Information gain. Information gain is used in ID3 and C45 algorithms. First, select the attribute with the highest information gain. Assume there are two classes P and N. Let the set of example S contain P elements of class P and N elements of class N. The amount of information needed to decide if an arbitrary example in S belongs to P or N is defined as. Then the information gain for P and N equal to minus P by P plus N, proportionate to positive example P by P plus N, uh, log to the base 2 minus negative example log negative proportionate to negative example to the base 2. Now, gain ratio. Gain ratio overcomes the problem with information gain by taking into account the number of branches that would result before making the split. It corrects information gain by taking the intrinsic information of a split into account. We can also say gain ratio will add penalty to information gain. Formula of gain ratio S for attribute A is equal to gain of S A and divide by split information of S A. Gini index, if a data T set T contains example from n classes, then Gini index or Gini of T is defined as Gini of T is equal to 1 minus summation of j equal to 1 to n and pj square, where pj is relative frequency of class j in T. If a dataset T is split into two subsets T1 and T2 with sizes n and n2 respectively, then the Gini index of split data contains example from n classes. The Gini index Gini of T is defined as Gini split of dataset T equal to n1 by n Gini T1 plus n2 by n Gini T2. The attribute provides the smallest Guinea split T is chosen to split the node. Need to enumerate all possible splitting points for each attribute. Now, question number 3. Define the mathematical expression of information gain, Gini index, and reduction in impurity. First, information gain. Let D the data partition be training set of class labeled tuples. Let class label attribute has m distinct values defining m distinct classes Ci for I is equal to 1 to m, and let CID be the set of tuples of class Ci in D, and let mod D and mod Ci comma D denote the number of tuples in D and Ci D respectively. Then the expected information needed to classify a tuple in D is given by information of D equal to minus summation of I is equal to 1 to m Pi log 2 of Pi, where Pi is the non-zero probability that an arbitrary tuple in D belongs to class Ci and is estimated by mod Ci, comma D divided by D. Information of D is the average amount of information needed to identify the class label of tuple in D. Information D is also known as entropy of D. Now, suppose we have to partition the tuples in D on some attributes A having V distinct values from A1 to AV. Then the expected information required to classify the tuple from D based on attribute A is information of attribute A in D equal to summation of J equal to 1 to V, then mod Dj divided by D into information of Dj. The term mod Dj divided by D acts as the weight of the jth partition. Information A of D is the expected information required to classify tuple from D based on the partitioning by A. Information gain is defined as the difference between the original information requirement and the new requirement, i.e., obtained it after portioning on A. Gain A equal to information of D minus information and of information A of D. Now the attribute A with the highest information gain is chosen as the splitting attribute. In simple words, assume there are two classes P and N. Let the set of S contain P elements of class P and N elements of class N. The amount of information needed to decide if an arbitrary example in S belongs to P or N is defined as then information of P and N equal to minus P divided by P plus N proportionate to positive example log proportionate to proportionate of positive example to the best 2 and minus proportionate of negative example log proportionate of negative example to the best 2. Now Gini index. If a data set T contains example from n classes, Gini index Gini of T is defined as 1 minus summation of j equal to 1 to n pj square, where pj is relative frequency. Then, if a dataset is split into two subsets T1 and T2 with sizes N1 and N2 respectively, then the Gini index of the split data contains examples from n classes. Then the Gini of T defined as N1 by N Gini T1 plus N2 by N Gini T2. Now reduction in impurity. So reduction in impurity is a measure of how much the impurity is reduced as a result of a split. It is related to the Gini index and is calculated as the difference between the impurity of the parent node and the weightage average of the impurities of the child nodes after split. Let I of S be the impurity of the parent node and T be the set of child nodes. resulting from a split. ST be the size of the child node T and I of ST be the impurity of child node T. The reduction in impurity Ri is given by Ri in S and T equal to I of S minus summation of where T small t belongs to capital T, ST divided by S mod dot I S T. Now, question number 4. Explain concept of overfitting and tree pruning. Overfitting is a common issue in a machine learning where a model learns the training data too well, including the noise and random fluctuations present in the data, to, to the extent that it negatively impacts the model's ability to generalize to new unseen data. In other words, an overfit model performs well on the training data but poorly on new unseen data. The model essentially memorizes the training example instead of learning the underlying patterns. This can happen when a model is too complex or has too many parameters relative to the amount of training data. As a result, the model captures noise as if it were a real pattern, and when faced with the new data, it fails to make accurate predictions. Tree pruning. Decision trees are popular machine learning algorithm, especially in the context of classification and regression tasks. Tree pruning is a technique used to prevent overfitting in decision trees. A decision tree is a hierarchical structure where each node represents a decision based on a particular feature, and each leaf node represents the output class level or regression values. Pruning involves removing certain branches, subtrees, or trees that do not provide a significant productive power or may be capturing noise on the training data. There are two main types of pruning. Tree pruning. Early stopping. In tree pruning, the tree is grown uh, to its full depth and then some branches are pruned or the tree growing process is stopped prematurely based on the certain criteria. Common criteria include limiting the depth of the tree, requiring a minimum number of samples in a leaf node, or setting a threshold for impurity measures like Gini impurity or entropy. Post pruning, cost complexity pruning. Post pruning involves growing the tree to its full depth and then pruning the branches that contribute the least to the overall predictive accuracy of the tree. A cost complexity parameter is used to balance between the complexity of the tree and its accuracy on the training data. Pruning decisions are made based on the parameter and subtrees with lower impact are pruned. By pruning a decision tree, it becomes less complex, more interpretable, and less prone to overfitting. Pruning is an important step in building decision tree models to ensure they generalize well to new data. Thank you.